Hello there folks, Cranky Old Cuber here. I've got another video on that Eurorack modular system kit that I've been building. This week, we're going to work on the VCF, or voltage controlled filter. What a voltage controlled filter does is it lets us pass or not pass various frequencies in the sound, so we can change the nature of the sound by blocking or emphasizing certain frequencies, okay? It's voltage controlled, which means that we can modulate it, which is what makes it modular. This kit is the kit that Moritz Klein did in partnership with Erica Sense, and you can still get the kit. Highly recommend this if you want to get into modular synthesis. Another way to do it, you could buy the Moog Mother 32, which is a semi-modular, which has basically the same components this does, but it's not fully modular. You can't jack into everything. So if you want to build something that gives you more control, this thing is a good idea. For me, this is just a gateway drug to modular because I'm probably not going to stick with just this kit. I can already see modules that I want to buy. So let's get the parts out, get everything sorted, and get to work building it. Okay, so we got the module built. It's here. It went together pretty nicely. It's a pretty good looking module. I'm not sure I'm sold on the PCB front panels. I feel like they're going to take a beating as you're, patching and unpatching and stuff, but we'll give it a try. And, if I need to replace these with metal panels, I can totally do that. So let's get the case and get this thing put in the case. Oh, look, it's a case. So we're going to put in our power there, and it's keyed, so as long as it goes in, it's good. All right, and I'm going to just pick a spot. Let's see, let's just say right here. Yeah, that works. And then I think its final spot is going to be right here. That seems right. So I've got a simple patch running here. It's just the square wave running into the filter and the filter's output running to the input of the output module. That's going into my sound system so we can hear it. So right now you're not hearing anything, and that is because the filter is completely closed, okay? I have the input from the VCO turned up as high as it'll go, but the filter is closed. It's filtering pretty much all frequencies. But if I sweep the filter up, it should start making noise. Yeah, there we go. Okay, so the filter's starting to open up. We're about halfway. And so now we're cutting most high frequencies. Yeah. And so now we've cut all the frequencies off. So yeah, that's interesting in and of itself. You can change the frequencies that go through. I'm using a pretty tame square wave, but you can hear it add those higher frequencies as I open it up, right? Another thing that you can do is this thing will self-resonate. And let me see if I can get it to do it. So if we take the input away from the filter and we run it into the control voltage, now we are opening and closing the filter, but we have no input. But you'll watch, as I turn this on, it's oscillating on its own. So that is all the filter. That's what it's doing. And that's called self-resonance. I'm going to change the frequency on the VCO and see if that makes changes to what happens. So what are we actually doing here? Well, I want to make the sound go away. For now, I want to look on the oscilloscope. Okay, so this is a view of our wave in the frequency domain. I'm using the spectrum analyzer on my scope, okay? What this shows us is the relative volume of all of the frequencies making up this signal. If I were to run a sine wave in here, which I can't do right now because this doesn't do a sine, but if I were to run a sine wave in here, almost all of the volume would be in the one fundamental frequency. So if I'm running this at 100 hertz, we would see a spike at 100 hertz. What we have here is a very noisy square wave, which has lots of frequencies and overtones, but it still drops pretty quickly. You can see it drop right here. All right. So watch though as I lower the cutoff frequency. It should take this part and shove it down. There we go. Now we're cutting the frequency down. And see, all these frequencies here are being very much lowered in volume. As we roll it off further, see how it gets even steeper here, where we've only got a few frequencies really contributing to the sound here. And then as we close the filter up, basically we've quieted everything except the fundamental. There's just a little bit of the fundamental getting through and maybe a couple of overtones. All right, so that's what we're going on. But if I turn this back up, then we're going to see that whole line start to go up, but it's going to start at the left end because those are our lowest frequencies. Okay. There we go. Now that it's getting more complex. Okay, so let's listen to it again while we watch this, and you should be able to hear the high frequencies going in and out. So right now we have the filter completely open. Let's turn it down. See, it's taken all that high frequency stuff out. Well, what's fun is you can actually control this thing with a control voltage, okay? And we're going to do that with the Happy oscilloscope too. So I'm going to set my function generator up on the oscilloscope to do a very slow sine wave. There we go. 2 hertz, do an amplitude of 2 volts. Okay, I've opened up the filter to about 12 o'clock. All right, now I'm going to start letting the CV, which is coming out of here, I'm going to start letting the CV modulate it. Okay, so we're feeding a sine wave signal into the control voltage, and it's opening and closing the gate and opening and closing the gate ever so lightly. Let's see if we can give a rhythmic element to it just by using an LFO. That is called an LFO, in case I didn't mention it. That is a low frequency oscillator. I'm going to have an oscillators video where I talk about what an oscillator is and what you can do with it and why we care. I'll do that soon. So what happens when we turn on resonance? Oh, now it's adding a little bit of that self-resonance. So that is basically a taste of what a voltage-controlled filter can do. This thing gets a lot more interesting when you use an envelope generator. Good news, I'll be building the envelope generator next. And once we have that, I'll be able to show you what we can do with an envelope generator, a VCF, and a VCO. This VCF also has a hidden feature you can't see because it's not on the front. On the back, there's a trimmer pot that you can turn, and that controls how off the hook the resonance will get. You can dial it back so the maximum amount of resonance is still pretty mild, but you can also dial it up so the max amount of resonance is just crazy, out of this world. That's pretty much it for this one. Next time we'll do an envelope generator and play with that, and after that we'll have the VCA, voltage controlled amplifier. That lets us shape the volume of a signal, and that'll be fun too. So with that, thank you for watching, and I'll catch you at the next video. Cheers.